Now, we've already talked about the least common multiple, or LCM for short. But now, we're going to be talking about the greatest common factor, or GCF. Now, before that, let's take the number 6 and try to separate it. We can separate it like 3 times 2. In one of my previous videos, we said that these numbers here, 3 and 2, are called a factor. So now let's try to find the greatest common factor, or GCF, of 16 and 12. How should we start? Well, we write the number 16. Now we look at all the numbers, or factors, of 16. So, of course, 1 is always a factor. And now, 2. Can we divide 16 by 2? Yes, we can. What about 3? No, we can't. 4. We can divide 16 by 4. And we go on. 5. We can't with 5. 6. 16 divided by 6. We cannot do that. 7. Nope. 8. Yes. 9. No. 10. No. 11. No. 12. No. 13. No. 14. No. 15. No. And 16. We can divide 16 by 16. And now we've reached the original number, so we stop. Let's do the same thing for 12. So 12 can be divided by 1, by 2, by 3, by 4, not 5, but we can do it with 6, 7, no, 8, no, 9, no, we cannot divide 12 by 10, and we cannot divide 12 by 11, but we can divide it by 12. And now we look at the numbers that are the same in both lists. So 1, 2, 4, and that's it. Now we take the highest number. Remember, with the LCM, or least common multiple, we took the smallest number because it was called least common multiple. Now we're looking for the greatest, so the highest number, which is 4. And that's it. The greatest common factor of 12 and 16 is 4. Now let's try to do it with the prime factorization method. So 16 can be separated 4 times 4. 4 can be written as 2 times 2, and this 4, 2 times 2. And 2 is a prime, so we cannot separate it. Now for 12. 12 can be written as 6 times 2. 6 can be written as 3 times 2. Now 3 is a prime number, and 2 is also a prime number on this 2. And now we look at the circled numbers, and we take the numbers that are the same. So for example, we have a 2 here and another 2 here. I'm going to circle them with another color. We also have a 2 here and a 2 here. Notice I did not circle these 2's. I did not circle these. Why? Because here I don't have another 2. If I had another 2, for example, something like this, I would circle this and this. But in this case, we don't have another 2, so that's it. And now from here, to find the greatest common factor, is very easy. So you just take one side. Let's say we take 12. And we only multiply the numbers that are circled in yellow. So we have a 2 here and a 2 here. Notice the 3 is not circled in yellow. 3 is circled in red because it's prime. But we don't have a 3 here. We don't have a 3. So we just take the numbers that are circled in yellow. And finally, 2 times 2 is 4, and you got your greatest common factor. Now let's try to find the greatest common factor of 10 and 15. Let's try to do it both ways. So the first way, we list all the factors. 10, and we said 1 is always a factor. 2, can we divide 10 by 2? Yes. Then 5, 10 divided by 5 is possible. And 10, these are the factors. And for 15, 1, 2 is not a factor. We cannot divide 15 by 2. 3 is a factor. 5 and 15. We look at the highest number, 5. This is the GCF, 5. Now with the other method, 10. 10 can be separated 5 times 2. 5 is prime and 2 is also prime. Now 15. 15 can be written as 3 times 5. And again, 3 is prime and 5 is also prime. And now we look at the same number. What numbers do we have that are the same? We have a 5 here and a 5 here. We said the GCF using this method, just take one side. I'll take this side, the number 15. And you write all the numbers that are circled in yellow. In this case, we only have a 5. And as you can see, we got the same answer in both methods. Now 18 and 25. So 18 can be written as 9 times 2. 9 is 3 times 3. And these numbers are prime. 25 is 5 times 5. And 5 is prime. Now we take all the numbers that are the same. But there's a problem here. All the numbers are different. So what happens now? Very simple. If all the numbers are different, there is no GCF. So let's try it this way. 1 is always a factor. 2, 3, 6, 9, and 18. For 25, 1 is always a factor. 5 and 25. As you can see, we don't have common factors, or we don't have a number that's the same, which means no GCF. We got the same answer with both methods. So try to find the GCF of these numbers. Write your answers in the comments. Thank you for watching. Please like, share, subscribe, and watch my previous videos.